Hi, I'm Michelle Davidson, and I'm going to be speaking about how to build a multi-cloud product that could run on more than one cloud and remain cloud agnostic, or in other words, independent of your cloud. So I'm going to start by speaking about why to deploy on the multi-cloud, why we wanted to deploy our products on the multi-cloud, some deployment challenges we ran into, why it was so important to us to remain cloud agnostic and how we achieved that, challenges we ran into around security and monitoring, and some key takeaways, which I hope will help you, whatever domain you're in, even outside the cloud. So a little bit about myself. I'm a software architect at Dell Technologies, where I lead our software architecture for the public cloud and our software architecture for security for PowerFlex, which is our software deployed storage product. I also like to blog about security and about architecture at Miss Architect on Medium. So you're invited to follow me there. And I sometimes am a guest lecturer for academic courses in cybersecurity. I'm going to start by why deploy your product on the multi-cloud. We're definitely seeing that's what enterprises are doing. In other words, that's what our customers are doing. And we're often seeing customers are deploying even on as many as 4 clouds. And now I want to ask again, why? Why are customers using more than one cloud? We all know the advantages of the cloud, but wouldn't it be simpler just to deploy on one cloud? And when we're taking our product and deploying it on the cloud, why aren't we sticking with one cloud? I would say the reason enterprises are deploying on the multi-cloud is because they're very afraid of vendor lock-in. They don't want to enter into a Catholic marriage situation where they start this great relationship with the cloud vendor, everything's hunky-dory, and then when they want to renegotiate their deal, when they don't want the prices to go up, they're stuck, they're trapped. So they always want this exit clause. And initially there was this thought that if you're deploying in more than one cloud, you've done enough, right? You're avoiding this vendor lock-in. I want to show you that's not enough if you're not intentionally designing your product to be cloud agnostic. So why cloud agnostic? I would say being cloud agnostic is the true cloud prenup. In other words, that's your exit clause to this relationship. That's the way you can easily end your relationship with a specific cloud vendor and move on to a different cloud vendor when your product is not tightly locked in, tightly integrated with a specific cloud. And that's something you want to architect for ahead, you want to design for ahead. And when you're cloud agnostic, when you don't have this tight coupling between your product and your business logic and the cloud vendor's underlying platform, that's what's going to give you that portability, the maintainability, instead of having that focus on constantly updating your product around cloud patches, and this interoperability of supporting these multiple clouds, which is a lot easier to do when you're planning for it upfront. So we knew that we wanted to take our product and deploy on the multi-cloud. How did we actually do that? Now, I'm not talking about one single straightforward deployment here. Rather, I'm talking about a dynamic deployment engine because the customer makes decisions, in this case around storage, what capacity they need, what IOPS they need, what cloud they need, what region, single AZ, multi-AZ. These are all decisions customers are making. Based on that, we're going to have a dynamic deployment engine. That dynamic deployment engine is then going to be going and deploying on the cloud. I just brought this as an example of a multi-AZ deployment with a load balancer and with attached storage. And that's just an example. Now, originally, when we were developing this dynamic deployment engine, we really thought we could take advantage of what was already out there in the industry. We were not trying to reinvent the wheel. So we looked at AWS CFT, but that's AWS specific. There's no way we wanted to write something totally different for AWS and Azure. Then we looked at Ansible. We had Ansible libraries actually for a previous version of our product. So we thought we can reuse them for the next version of the product. But then we saw that even though Ansible theoretically supports Azure, it's using a totally different library. We need to handle it in a totally different way. It would be a major rewrite. We didn't want to do that. Then we looked at Terraform. Terraform was the most, seemed like the most popular, but again, we had that same challenge where you don't have a true multi-cloud library. It's not really cloud agnostic. You have these very specific details for AWS and Azure. And we looked at Pulumi, which I was actually quite keen about because it does allow using imperative languages for writing your deployment framework. It doesn't, for instance, Python. Again, because it's using these Terraform constructs under the hood, it's using that very cloud-specific language, and we rolled it out. We didn't see it as truly multi-cloud. This is the point where you're probably thinking, what's the big deal? So there were different languages for AWS and Azure. Fine. Take advantage of what it's offering. But this is where I want to take a step back and say that language is very powerful. And when you're locking yourself into a specific cloud vendor's language, you're locking yourself not only into communicating using that language, but also thinking about the cloud vendor in that way. And that's making it a lot more difficult for you to move from cloud vendor to cloud vendor. And when you actually look at the history of technological developments, initially we had these open standards, right, like HTML, HTTP, and that enabled really the World Wide Web, right? That enabled everyone around the world to communicate using a single language, and that was incredibly powerful. Now, the faster technology kind of changed, which we definitely see it's, changing pretty fast. Open standards were not keeping up. We introduced industry standards. We thought if we had a few industry movers and shakers, they really want to get things done. This is going to happen faster. For instance, with BGP, TCP/IP. Now, it definitely improved, but I can't say as someone who has been in one of these standards committees, yeah, like you can be spending 3 months talking about like a specific line you want to change in one standard. But I think open source really is where we're able to keep up with the pace, right? Well, everything we're seeing around, for instance, Kubernetes, it enables everyone to commit the changes, enables everyone to consume them. It's less of a bottleneck that you have with the standards committees, and you still have this common language. For some reason, when it comes to the cloud, we let the cloud vendors get away with these cloud-specific languages. I'm not sure why. Maybe originally we didn't understand the importance of the cloud, and then we just accepted it. But for some reason, when you talk about the cloud, very different from any other industry, you're going to see this totally different language, right? AWS and Azure, totally different terms. And I think that was actually intentional. I don't think it was that the product manager and Microsoft wanted to be creative, and that's why he called his storage blob. I think what actually happened here with the cloud vendors is they made it much more difficult for people using these clouds to actually be able to compare between them, to be able to move from one to the other, use one if they're familiar with the other. And that's a new term that I want to call engineering lock-in. And I think that's a key concept here. We're always thinking about vendor lock-in, but let's actually think about the most precious resource in R&D companies, which is ourselves, the engineers. When we as engineers are locked into a specific vendor by using their language, that makes it a lot harder for us to take that step back, compare the alternatives between cloud vendors, and just actually go and ramp up in a new language. If you're able to think about things in a cloud agnostic way, that's going to give you that freedom and that flexibility. So think about the engineering lock-in happening in your industry, in your product, when you're very much tightly coupled with a single cloud. So we knew that we wanted this cloud agnostic language. I explained, I hope, the importance of that. Now, how do we do that? We did look at Tosca, which was an existing cloud deployment framework. However, it didn't seem worth really the investment. It didn't really justify the ramp up for taking advantage of Tosca because what we needed to do was relatively simple. Instead, we did make the decision to invent our own cloud domain specific language in this case, but something very, very lightweight, very simple that anyone can implement, where we're just doing this mapping of a key to a value. The key is always going to be cloud agnostic and the value is cloud provider specific. Very simple, right? So for instance, if you have a VM is something cloud agnostic. Whatever cloud vendor you're in, you're always going to have a VM. And now if you're in AWS, you need to give the AMI ID. If you're in Azure, you're going to need to give the Azure VM ID. But that mapping can still be translated into something which is generic, a VM. Or in our case, block storage. Every single cloud vendor has block storage. In AWS, it's called EBS. And that enables you to do that mapping, enables you to think about your cloud in a generic and an abstract and agnostic way. So now we had that down. How did we actually develop this deployment language and become cloud agnostic? We ran into another challenge because when you look at the infrastructure, you see very similar infrastructure. But when you look at the SaaS services we tended to take advantage of, they were very different per cloud vendor. And that's the point where I had this, I would call it a realization that when you have a single problem, it's not necessarily correct to tackle that single problem in a single way. Sometimes if you take that problem and you split it into a few problems, this might sound unintuitive, but by splitting it into a few problems, you're actually able to solve each problem differently and better. So you may have a few solutions to a few problems, and each solution is going to be more correct. And I'm going to explain what I meant here. Instead of thinking about the cloud as a blob, okay, how do I solve the cloud deployment? Can a cloud deployment be abstract or not? Does it have to be cloud specific? I stopped and I said, okay, we have the infrastructure that I asked, which is the storage, the servers, the networking. That is something that can be looked at abstractly, can be looked at cloud agnostically. The CDSL we invented will solve this. When it comes to the SaaS services, yes, the cloud vendors did come along afterwards and add all these great SaaS services that we want to take advantage of and integrate with. And there are differences. Let's handle that in a different way. By doing that split, we're actually still able to attain our cloud agnostic goals. When it came to the infrastructure, we said, okay, we have these VMs, we're deploying on VMs, we're a software first product, which means we can run on VMs. We don't even have to think about the fact that it's a cloud. We can pretend that it's on-prem. Really a lift and shift. Now, there are some tweaks for the cloud, right? There were some libraries we needed for the cloud. There were some differences in the operating system, but it was relatively straightforward because we were just thinking about how to deploy our software on infrastructure on the cloud, the same way we're doing it on-prem. When it came to taking advantage of SaaS services, there we needed to think, okay, how do we take it? How do we use these SaaS services? How do we integrate with them? Which is something we sometimes wanted to do. And that's where we also realized, using these SaaS services is something we're going to do across products. So we want to do this in a common way. And that's where I come to a common cloud framework. When you have multiple products all deploying on multiple clouds, it really makes a lot of sense to have reuse here and not to have every single product going and doing its own cloud integration from multiple clouds. This is better for maintainability, better for initial investment. If you're in a similar situation within your company, I would really encourage you to think, can you build some kind of common cloud framework? If you're in a smaller company where you have a single product, I still think there's a huge potential for some kind of open source library here because it really doesn't make sense that every single product is coming along and deploying first for the cloud for multiple clouds. When you actually look at things in a more abstract way, you see, okay, we can build something great here and generic and common, and then we could just handle those details under the hood. Every single product should not be solving the same challenges on their cloud journey. So let me just translate this into what we did technically. We knew we had this software we needed to deploy, our product software, which I'm calling it PowerFlex software. We knew we wanted to deploy on infrastructure, on AMIs in the cloud, on EC2 instances. We wanted to be able to think about the software as just a straightforward software installation without caring if we're on-prem or on the cloud. And then people kept coming back to me with the question, but can you really build a common framework? Because the only person, like the only entity that knows what infrastructure needs is the product. So you need the product to say what infrastructure needs before it can deploy the infrastructure. And here's where we did the splitting of the problem. The first problem is, how do we know what infrastructure we need in our cloud? And that's why I call the glue, because only that specific product on that specific cloud with those customer requirements, which change from customer to customer, can make these decisions. What's the infrastructure I need? That's in a single place, and that's something that's easy to update. So if we have new versions of product which require different infrastructure or new cloud infrastructures released that we want to take advantage of, we just change in that single place in this planner where we're doing this planning. What's the infrastructure we need? When it comes to actually going and deploying the infrastructure, that's totally product agnostic. We don't care what product we're doing it for in Dell, right? Or in your company, you don't have to care what product you're deploying your infrastructure for. You just need to go and deploy the infrastructure. And that's where there's this huge potential for commonality. You just go and deploy the infrastructure. Now, under the hood, you're probably integrated with these cloud-specific libraries, but you can keep that abstract at the higher level. You're just saying what infrastructure you need, and then you're going and calling the specific library to do that cloud deployment. In the third stage, you want to go and deploy your software. That's just a software-only deployment. So at that point, you don't need to care if you're on the cloud or on-prem or what cloud you're on. Are you on AWS or Azure? You're just going and installing your software. So by splitting this into 3 stages, again, we were able to keep a lot of flexibility around our infrastructure and really make sure that a lot of our code could be common and could be reusable. Now the question is, how do we actually communicate? How does this planner making a decision what infrastructure it needs tell this common cloud framework the infrastructure needs without using a cloud-specific language? And that's the place where the CDSL we invented came into play, because it's just saying, I need a VM, and the VM is an AMI of this key. I need block storage, and the block storage is EBS of this type. But the actual communication, the actual API, the actual architecture, all of that is cloud agnostic. Now, when it came to monitoring, again, we ran into a minor challenge because we knew we wanted to take advantage of the cloud service monitoring, such as CloudWatch, or even these great third-party tools like Prometheus. On the other hand, we did have our existing products, existing monitoring, in our case, Dell's Cloud IQ. We didn't want to throw all that in the garbage, right? We wanted to be able to carry on using what we already had around product monitoring. What we actually did here was we collected into a single data lake both the product software monitoring, which is at the software level, and the cloud infrastructure monitoring happening at the cloud level by, for instance, CloudWatch. And they're both being collected in a single data lake mapped to each other. So when the customer views the product, they're seeing both the software information, the product information, and the cloud infrastructure information. And it's transparent to the customer that there's actually two different monitoring systems under the hood. So here my advice is, if you run into a similar challenge, think if you can carry on reusing your existing monitoring that you have on-prem and just adding to that with this cloud monitoring for the cloud aspects instead of tossing everything out and replacing everything. When it comes to security, even though until now I said we could really take a lift and shift approach because our product is software first, I definitely want to caution you not to do that when it comes to security, because really the attack surface is so much larger in the cloud, and there are these changes around key protection, around the ingress egress, around multi-tenancy, limited hardware security. That does mean you have to rethink your security posture in the cloud in order to improve your security posture in the cloud. So we did want to take advantage of cloud-specific services in the cloud, such as Secrets Manager and such as KMS. I'm just going to quickly touch on an example here without getting into details. When we create an instance, we get an SSH key. How do we store that key? How do we send that key to our customers? Because it's actually their instances in their account. So we did have a bespoke solution. I'm not going to get into the details. It was pretty complex, definitely reinventing the wheel. When we looked at the cloud vendor solution, it seemed great. We can push the keys into Secrets Manager, but then we have this tight coupling between our product and the cloud-specific libraries. And this is where something really simple abstraction came into play, and we were able to take advantage of that abstraction by having that realization that the way we tackle infrastructure and the way we tackle services in the cloud is going to be different. So when it comes to services in the cloud, like security services, we just used abstraction. We said, okay, we're going to have a common security service. The product is going to use that security service. It's going to be transparent to the product that's happening under the hood. And then we're going to use that common cloud framework to actually call the cloud-specific security service, in this case, KMS and Secrets Manager. So this is just abstraction, but it was super powerful in this use case. I would say that when you're going into multi-cloud security, you do have a lot of thinking to do, but that's not the topic of this lecture. I do feel it's a fascinating domain. Now, in terms of takeaways, there are definitely pros and cons when it comes to being cloud agnostic in the cloud. I feel it's really valuable when you have multiple products on multiple clouds. It enables a huge amount of reuse and commonality, and it prevents the engineering lock-in. It enables your most precious resource to maintain their independence and to easily think about, assess, and move from one cloud platform to the other. When it comes to cons, it definitely is a higher upfront investment, and it's something that is really only worthwhile if you are thinking about the multi-cloud. And ideally, until we have this open source framework I'm dreaming around, ideally when you are deploying for more than one product. And now I promise you 3 key takeaways, whatever domain you're in. And they're, first of all, language matters, and to avoid this engineering lock-in, which can be so costly. Second of all, divide and conquer. Sometimes when you have one big problem, split it up into separate problems, and then each problem you can solve in the way that's most correct for that problem, like we did for IS and SAS, which we solved in different ways. And third of all, abstraction, something very basic that you learned a lot, hopefully, in your degree. And that's something that you can really just apply, and it's super powerful. So don't underestimate abstraction. It's what helped us tackle the problems we had around security and remaining cloud abstract. So thank you very much, and feel free to be in touch with me anytime. I'm Miss Architect on Medium, and I'm also available on LinkedIn and Gmail. Thank you.